I'd like to show you how to use one of the oscilloscopes in the lab. And other oscilloscopes you might use in your research career will be very similar. You switch it on with this button over here, wait a while until it comes up showing you a plot like this. Now what the oscilloscope is doing is showing voltage as this line across the middle against time. And because nothing is plugged in, there is no voltage at any time. We're now going to feed it a periodic source on this cable, which has come straight from the function generator. So let's plug it in. And we've got some rather ugly looking pattern going on here. What's happening here? Well, it's plotting whatever this function is over and over again on top of each other, and it's not lining up with itself. So, for example, the first wave might start halfway up, the next wave might start at the bottom, and so you've got lots of different waves plotted on top of each other, making a big mess. So what can you do about this? The obvious technique is to press this little button up here called Auto Set. These oscilloscopes are pretty clever, and if you press that button, it will try and figure out for itself what's a good way to plot the data. And here it's succeeded in doing so. It's given us a plot, and it looks like we've got a sine wave. How is it plotting it all on top of each other? There's a certain interval of time here, which is probably not going to be exactly the period of the sine wave. So normally if you just plotted and plotted and plotted over the top, like an oscilloscope does, each wave would not line up with the other thing. The answer is something called triggering. This little arrow here tells you the level it triggers at. What it does, it plots one across one set of waves, and then it waits until the voltage is at the trigger level before it plots another one. This means that all the waves line up on top of each other, so it all makes sense. We can adjust the triggering level. If we adjust it outside the range of the data, you'll see what happens if it doesn't line up anymore. But if we put it back inside the range of the data, everything is nice. You can switch Auto Set off and get the same effect by yourself. What we need to do is adjust the frequency. This looks like it's really solidly black, so the frequency is much higher. This button's here, the one that says horizontal at the top, adjusts the horizontal scale, which is a time scale. At the moment, it says it's 10 milliseconds per one of these square boxes. Let's make it 5 milliseconds, or 2.5 milliseconds, or 1 millisecond. Now we'll begin to see what's happening. Now let's adjust the trigger menu and adjust the trigger. So we press that button to get the triggering going, and now we've done the same thing with the automatic thing, as we've found the correct period. To adjust the plot, if you want to move it horizontally, this button, as you've already seen, changes the time scale. So now it's 100 microseconds per box, and now it's 250 microseconds. This is equivalent to zooming in and out on the horizontal scale. You can move left and right by changing this button here, turning this knob up here. Vertically, this allows you to move up or down, and this one gives you the vertical scale, which is how many volts give one box. So at the moment, 2 volts per box. If you go down to 5 volts per box, it all looks nice. So this is adjusting the vertical scale, and you can make it look smaller like that.